All right, everyone, and we are back. So, in our journey in learning about statistical analysis, we have to kind of start with experimental design and what are our goal. And really, if you boil it down, an experiment is all about taking a measurement. So, when we take a measurement, we want a quantitative comparison between some standard and a measurand. So we can measure temperature, length, time, stress, strain, viscosity, force, torque. Lots of different measurements are available to us as engineers. So when you're doing a measurement process, you have some input quantity, which is the measurand that you're looking at. When you're comparing against a standard, it has some relationship to some type of unit of measurement. So there's some, basically associations that recognize standards, but a standard could be if you're measuring length, tape measure, weight, mass, balance, speed of light. You could measure that's actually a reference, time, stopwatch, extensometer, et cetera, et cetera, et cetera. And again, we want to measure things and we want to grab these quantitative values, especially for state variables, temperature, pressure, all those things. It's important for thermodynamics. It's incredibly important that we measure things for control processes. So again, measurements are everywhere. So daily operations, again, temperature controls, heating and cooling, mass, and having precise and reproducible measurements. Again, it has real life consequences. So if my measurement is off, and titanium is $140 per pound is probably much, 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 much more now. Actually, let's look at this real quickly. Sorry for the tangent, but you all know titanium cost per pound in 2023. Or titanium it's probably titanium sheet. 400, yeah, it depends, but it could go, anywhere from 400 to probably now like 600, 800 with, but anyways, measuring temperature for bacterial growth. Again, these are all types of measurements and measurands that we want to do, or want to perform. But again, we need to specifically, using statistical tools and statistical frameworks, we need to determine essentially uncertainty. So no measurement is meaningful unless you give me an associated error bar. If you say, Professor Steimel, the mass is 5 kilograms, that doesn't mean anything if you say plus or minus, et cetera, et cetera, et cetera. We have to no measurement is perfect. Again, there's always going to be some uncertainty. And the value of your measurement becomes meaningful only if you give me those error bars. What do I mean by that? Well, specifically, let's say I'm measuring, something, y versus variable x. If I measure, this is my mean, my data point, and my error bar here. But let's say this is my mean here, and my error bar is here. Which of these two measurements is higher? 1 or 2? Well, the mean of 2 is greater than the mean of 1, but my error bar essentially tells me the range of measurements that I can expect. They overlap. I can't say anything about one being greater than another. Like those error bars, now how do we create those error bars? You'll see a little bit later on in this course. But that is what tells me the difference, or if there's a statistically significant measurement. So I need those error bars. In this course, you always have to put those tolerances, that uncertainty, the confidence interval. We've also touched upon it a little bit already, but it is very important that we use the correct terminology when you are looking at an apparatus or a measurement. Accuracy. Accuracy is the difference between the measurand and the true values. Again, I told you that we don't care about true values, but again, that is the definition of accuracy. The comparison or the difference between measured and true. Precision is the differences between reported values of repeated measurements. So I have high precision if that difference is small. I have low precision if that difference is large. Resolution. What's the smallest increment that I can measure? High resolution would be a micrometer, where I could measure a micrometer. Low resolution would be a yardstick, where I could measure a yard. Sensitivity and resolution are kind of related. So it's the change of instruments output per unit change in the measured quantity. So again, higher sensitivity is usually finer resolution, better precision, better accuracy. Excellent. So that is a little bit about language, and next time we're going to get into what are the types of error and uncertainties that you can encounter and how we're going to deal with those. So see you in the next lecture, or the next video. Bye.